Now let's solve here question number 36. Here you can clearly see we have choice in this question, where the first choice states using integration find the area of the region bounded between the two given circles, and in the second choice it has been stated evaluate the following integrals as limit of sums, and we will be firstly proceeding with the first choice. In this choice, as we are talking about area of the region bounded between these two circles. So this is a very basic question related to chapter of application of integral. In this circle, you can clearly see we have the equation x square plus y square equal to 9, where 9 clearly represents 3 square. So this represents a circle having center at origin and radius is 3 units. Talking about the second circle, here this is x minus 3 whole square plus y square equal to 9. So this represents a circle having center at 3, 0 and radius is same 3 units. So very first thing we need to do is constructing these two circles. After drawing these two circles, you can clearly see that their centers are marked at origin and point 3, 0. So this is the region bounded between these two circles. Let me consider this as circle 1 and this is the circle 2. So circle 1 represents x square plus y square equal to 9 and circle 2 represents x minus 3 whole square plus y square equal to 9. So firstly we need to obtain the point of intersection of these two circles. You can clearly see this is the bounded region. So these will be the 2 points of intersection here. Now from this we get a clear idea that y square can be represented as 9 minus x square. This value of y square as 9 minus x square can be easily substituted in the equation of second circle. After doing this substitution, you will be able to get here the value of x. So x square will get cancelled on expansion, and here on simplification it will result minus 6x plus 9 equal to 9, where on further simplification x is 3 by 2. You can easily substitute this value of x back in this first equation, resulting here two possible values of y, that is plus minus 3 root 3 by 2. So here we have this point of intersection 3 by 2 comma 3 root 3 by 2, and here we have this point of intersection as 3 by 2 comma minus 3 root 3 by 2. So here in this case I can clearly see that this is the point of intersection. This is the bounded region which is being divided by x-axis in two parts. So what best can be done? Here we can consider area of the first part, which is the upper part above the x-axis, and twice it up to get the required shaded area, which is the required bounded area between the two circles. So for obtaining this, here we have the equation of the second circle. This is the point of intersection at 3 by 2. So I can take here limit from 0 to 3 by 2 for this second one, and here at this point you can see here we get the first circle having the limit from 3 by 2 to 3. Taking that into criteria, I'll be obtaining here the required area, that is twice of the area of the upper part having the limit from 0 to 3 by 2. You can clearly see for second circle the value of y square is 9 minus x minus 3 whole square. So value of y will be square root of 9 minus x minus 3 whole square, plus I have here integral from 3 by 2 to 3, where the value of y will be integral square root of 9 minus x square dx. So in this case, as we need to figure out this required area, so I want you to recall a very important formula, that is integral of square root of a square minus x square dx. This is clearly given by x upon 2 square root of a square minus x square plus a square upon 2 sine inverse x upon a. Same formula will be applied in these both integrals. In this first integral, in place of a, we have here a as 3 because 3 square gives you 9, and in place of x we have x minus 3. While in the second integral, in place of a we have 3 itself, and in place of x, x itself. So applying the same formula here in these two integrals, the area becomes this, that is x minus 3 upon 2, which is representing x by 2 square root of a square minus x square, plus I have a square upon 2 as 9 upon 2 sine inverse x upon a gives me x minus 3 upon 3, having the limits 0 to 3 by 2. While the second integral now becomes here x by 2 square root of 9 minus x square plus 9 by 2 sine inverse x by 3, having the limit 3 by 2 to 3. Now substituting here upper and lower limit. So when you will be substituting here 3 by 2, then this will become equal to 3 by 2 minus 3 upon 2, reducing it to the value 9 root 3 upon 8, because when you substitute here 3 by 2, this whole value will get simplified. Further, here we have 9 by 2, 3 by 2 minus 3, resulting here minus 3 by 2 upon 3, that is minus 1 by 2. Now substituting here the lower limit 0, this gives me here 0 minus 3, 9 minus 3 square, that becomes totally 0. So this gets cancelled up, while here I get 9 by 2 sine inverse minus 3 upon 3, that gives me sine inverse minus 1. So I get here minus 9 by 2 sine inverse minus 1. Now coming to the second integral, where firstly I'll be substituting the upper limit 3. So that gives me 3 upon 2, 9 minus 3 square, this becomes 0, plus I have here 9 by 2 sine inverse 3 upon 3, that is 1. So I'm getting here plus 9 by 2 sine inverse 1. And when I am substituting here 3 by 2, I'll be clearly getting here 3 upon 2 whole by 2, which will become 3 upon 4, and here 9 minus 3 upon 2 square simplifies to the value minus 9 root 3 upon 8. Then here it becomes minus 9 by 2 sine inverse 3 by 2 upon 3 becomes clearly equal to sine inverse 1 by 2. And you are aware the value of sine inverse 1 by 2 is simply pi by 6. So here the value of sine inverse 1 is pi by 2. So substituting all these values here, this further reduces. So here this minus 9 root 3 by 8 and this minus 9 root 3 by 8 gets added up, and you get here minus 18 root 3 by 8, which further reduces to the value minus 9 root 3 upon 4. Next we have here 9 upon 2 sine inverse minus 1 upon 2. So this will become minus 9 by 2 into pi by 6. Same goes here, we have minus 9 by 2 into sine inverse 1 by 2 is pi by 6. So these two gets added up to give you minus 18 pi by 12, which reduces to the value 9 pi by 6, that is minus 9 pi by 6. Here we have minus 9 by 2 sine inverse sine of minus pi by 2, which becomes here plus 9 by 2 into pi by 2, that is 9 pi by 4. Same goes here, 9 by 2 into pi by 2 gives you again 9 pi by 4. So these two gets added up to give you 18 pi by 4, which reduces to the value plus 9 pi by 2. And when you simplify this whole and multiply 2 to these terms, this reduces to the value 6 pi minus 9 root 3 upon 2 square units. So this is the area of the region bounded between the two given circles. So this is your required answer for this question. This was a 6-marker question, and in this question, when you have obtained the required points of intersection till this step, you will obtain complete 1 mark. After that, for obtaining these correct limits, that is from 0 to 3 by 2 and 3 by 2 to 3, and getting this equation, here you will obtain another 1 mark. For writing this formula correct and mentioning it rightly here, you will get 1 mark. So don't miss out on writing the formula. Further, on applying the limits here, you will get here another 1 mark, and putting here the limits, that is upper limit and lower limit, and further simplifying it, here you are going to get another 1 mark. And finally, on obtaining the required area of the bounded region between the two circles, you will obtain rest 1 mark. That gives you total 6 marks for this question. Now let's proceed to the choice given in the same question. Here in this choice, we are talking about evaluating this integral as limit of sums. So here this is integral 1 to 4 for x square minus x dx. Now as you have to evaluate it as limit of sum, so I want you to recall this important formula which we use for limit as a sum. That is integral a to b fx dx is equal to limit h tending to 0 or n tending to infinity, where we have h into f of a plus f of a plus h plus f of a plus 2h, so on till f of a plus nh. So here nh is equal to b minus a, that is upper limit minus the lower limit. Same formula we will be applying over here. And when you apply this formula for this given integral, here we have x square minus x. For both of them we will be applying this formula. So I get here limit h tending to 0 or n tending to infinity, h into, I have 1 plus h square, where I am considering firstly for x square term, 1 plus h square plus 1 plus 2h square plus so on till 1 plus nh square. Next I have here minus x, that will be written as minus 1 plus h plus 1 plus 2h, so on till 1 plus nh. In the next step, I will be simplifying it. So in the next step, here you are going to get limit h tending to 0 or n tending to infinity, where we have h into these square terms. So you will be simplifying all these square terms, and when you will be expanding it, on expanding each and every square quantity here, you will be getting here 3 terms. Using the basic algebraic operation, I get here 1 plus 2h plus h square for the first term. Next I get 1 plus 4h plus 4h square, and so on. Next you will find that here we have minus this term where we have 1 plus 1 plus 1 so on till n times. So 1 added n times gives me here n, plus I have h into 1 plus 2h plus 3h so on till nh. If I take h common, I get here 1 plus 2 plus 3 so on till n. So next I need to simplify it further. So here you can see in this term, if 1 1 1 is being added till nth term, I will be getting n for that, and I have here this middle term as 2h, 4h and so on. So if I take here 2h common from all of that, I will be getting there 1 plus 2 plus 3 so on till n times. If I take h square and here h square common from all these square terms, it will result here 1 plus 2 square plus 3 square so on till n square. That is sum of n square terms. So ultimately you are going to get here that this expression is being reduced to this form, where you can clearly see here in the first bracket, here we have 1 added n times, that is giving me n, then 2h is taken common, that gives me here sum of n natural numbers. Further, when h square is taken common, that is giving me sum of square of n natural numbers. While here in this bracket we have n, h into so on till n natural number. Further, it could be simplified, and in the next step here we can apply the formula of sum of n natural numbers. What is that? That is n into n plus 1 by 2. And here I can apply the formula of obtaining sum of square of n natural numbers. And what is that? That is n into n plus 1 into 2n plus 1 whole by 6. The same formula of sum of n natural numbers can be applied here. Moreover, when you will open up these two curly brackets, here n will get cancelled. So I am going to get here in this step limit h tending to 0 or n tending to infinity, where you have h multiplied with this term. So this is 2h into the sum of these terms, where I have this term subtracted to it. On opening up this bracket, you will get here minus h into sum of n natural numbers, and here you already have 2h into sum of n natural numbers. This will get simplified, and ultimately you are going to get here h into sum of n natural numbers, where sum of n natural numbers is n into n plus 1 by 2. So this is the resultant term, while here I am getting h square into sum of square of n natural numbers as this term. In both of these, this will be further simplified, and on further simplification, here you can clearly see that in this step, further on opening up the bracket, I will be getting here n square h square, where I have taken here this product, which is resulting me here n square h square as common. On opening up the bracket, n will get multiplied to these both terms, and after that n square is taken out as common. Same I will apply here. I am taking product of all these terms, where I am taking out n cube as common. So now in all these steps you have n tending to infinity. So when n is tending to infinity, 1 upon infinity is 0. So on putting this limit, here 1 upon n will become 0, this 1 upon n also will become equal to 0. So here in this case, ultimately you are going to get this value, because we already know nh is equal to b minus a. So in this case, nh will be equal to b minus a, where upper limit is 4 and lower limit is 1. So this is equal to 3. So I am going to get here 3 square 9 upon 2, where this is 1 plus 1 upon infinity, that is 0. So I am getting here 9 by 2. Here I am getting 3 cube upon 6, that is giving me 27 upon 6 into 1 into 2, which is further reducing to the value equal to 9. So 9 plus 9 by 2 finally gives me the answer as 27 upon 2. So this is the required answer for this question. The value of limit of a sum is 27 upon 2. So in this manner, you can answer the question using limit as a sum. So this was a 6-marker question. In this question, when you write this correct formula of limit of sum, you get here complete 1 mark for this. Next, when you apply this formula to the given definite integral, here you get another 1 mark. In the next step, when you do this expansion, you are going to get another 1 mark. After that, when we are substituting these values and simplifying these terms by clubbing the square terms together and constant terms together, in this step you will obtain another mark. After that, when you are putting here the formula of sum of n natural numbers and sum of square of n natural numbers, in this step you will get 1 mark. And when you are substituting here nh is equal to 3 and putting here the limit n tending to infinity, finally getting this answer gives you another 1 mark for this question. That gives you total 6 marks for this question. So here we come to end of this paper where we have discussed all the questions. I hope all the questions are clear to you. So this paper was from moderate to difficult level, and this was as expected as previous year trends. I hope you will be doing great in your examinations. All the best for your results. Thank you.